Today you're being told that you're being given one of the factors. It is almost a guarantee if you read it properly. Given a polynomial and one of its factors. Stated for a fact. Determine the remaining rational factors of the polynomial. What I said yesterday, remember, rational means you can factor them. If you can't factor it, that's too bad. It's done. That's as good as you can do for now. So some factors may not be binomials, and you'll see one of those today. Now, x plus 4 is the factor that I know goes in there. So why don't we take that one out? Because you agree that there are 3 total? 3 little pieces because it's x to the third. So there's 3 little pieces. How many do I know already? I know one of them. So why don't we take out the one I know? Because then we'd be left with only 2. What kind of function is it when it's x to the second? What are those in general called? Called quadratics. And you have a lot of ways of solving those. So why don't we take that one out? And the easiest way is synthetic. So you make your little box. What are you going to put in there? The -1. Again, the real reason is because that's the actual 0. If you solved it, that's what you would get. Or some people have always learned just change the sign of that number there. And then here we would have a 1, a -1, a -5, and a -3. Now, I believe yesterday we had some zeros along the way. Should we have any of those here, like a 0 along the top here? No, because we have all the terms, 3, 2, 1, none. And watch out, I may give you a problem or two where I don't put them in descending order. So make sure you do that before you set up synthetic. But the nice thing is, and there's your remainder bar, I can actually put something else in here before I even start the problem. Or I should know what one of the numbers is going to be before I even get started. I should know this number right here. That remainder better be 0. Or they lied to me, or I did something wrong. Because if they're telling me it's a factor, that better be 0 sitting there when we're done. And so you bring down this first term, which happens to be a 1, and then the splash effect. And so that's, careful, -1. Do you change your signs? Not in synthetic. And so what are you left with? -2. Splash effect, you get 2, -3, 3, 0. Okay. So now we have to look at this stuff down here, because that's basically the stuff that's left over. Okay, and remember, we started with x to the third, so this one here must be x to the, we took 1 out, x to the third, this better be x to the, so it's 1x to the second, minus 2x, minus 3. My job is to find any more rational factors, which means, can I factor that? Because it's x squared. That's a trinomial, 3 terms. The way to do that is key number factoring. I did it briefly at the very end of class yesterday. To do key number, this is the way that I've always set it up. There's a 1 here, so it has to multiply to be whatever those multiply together to be. 1 times -3 is -3, and it has to add to be the middle number, -2. It is very possible that those numbers don't exist. But are there 2 numbers that when I multiply them I get -3, and when I add those same 2 numbers I get -2? Do such numbers exist? They do. They are -3 and a +1, correct? Okay, this is called key number factoring because those are the key numbers. Those are the numbers that are going to make it work. And those, again, depending on when you had Algebra 2 and who you had it with, this is commonly referred to as the pants method by the last bunch that I taught. So the x squared just comes right there. This -2x does get divided. And remember, does it matter what order I put those 2 in? The -3 and the 1, does it really matter? No, whichever. So we'll say -3x plus 1x, because if I were to put them together, it is -2x. That is the same thing. And then -3. And again, the real reason from going from 3 to 4 is because of the highly technical term of squiggle that you get to put right there. And all it does is divide up the stuff so you can see it. Don't expect to see the squiggle if you go on to school somewhere. x. Because that's what's in common here. And then we're left with an x minus 3. So that's what I need to get over there. And can I get it? I can, but I still have to take something out. And the only thing I can take out and still get x minus 3 is a positive 1, correct? And so one of my factors is the one that matches x minus 3. The other factor is x plus 1. And I hope to clarify all of this. If my original was x to the third, how many little pieces should I have? At least if they're all nice, I should have 3 little pieces, correct? Here's 2 of them right down here, x minus 3 and x plus 1. Where's that third one? Yeah, it's the x plus 1 we were given. What that means, this is basically the answer to the question. Those are the remaining factors. It means if I take all 3 of those, multiply it all out, foiling all over the place, what am I going to get? Yeah, you're going to get right back to where you started. Okay? We're trying to break it apart. We're trying to find what pieces made it. And for now, we're only looking for the nice factors. In other words, instead of calling them nice, I call them, much more technical term, rational. Okay. Any questions on what I did? No? All right. Looks like I believe I gave you a second example. Why don't you try that one now? All right, let's see how you did. Well, is x plus 7 actually a factor? Does it work? Is x plus 7 actually a factor? Okay. So you went through it. Yeah, and you found out you threw a negative 7 right there. You got a 1, 6, negative 4, 21, right? Okay. Now you have to put the stuff back in, and if it was x to the third, I took 1 out, so it is x to the second minus 1x plus 3. So if we kind of do it the way we did before, we kind of walked over here and said, all right, now we got to try and key number factor that. And it has to multiply again. Don't forget to multiply those numbers. That's what a lot of people start doing. It's not always going to be a 1 out front. There could be a 2 there or something, and that throws things off a little bit. You got to make sure that you do take care of that. So multiply to be 3, add to be negative 1. And the key here is, are there rational numbers that will do that? Are there actually numbers out there somewhere that would actually do that? Yes, there are, but they're either irrational or imaginary. And do we want those right now? No. I told you rational flat out. So if you can't find them, then you did as good as you could. Then right there, are the remaining factors in there somewhere? Yeah. They're in there. Am I asking you to get those particular ones out right now? No. The other factors are right there. That's as good as you can do for right now. Again, if I took that times x plus 7, I'm going to go right back to where we started. Okay. So do you understand what I'm looking for when I say find the rational factors? Okay. All right.